Hello everyone, in this video we are going to see about the spanning tree. So we have learned the data structures about what is graph and what is a tree, and we know that the graphs have cycles and the tree has no cycle. That is the basic definition of a tree. Difference between the graph and the tree is graph have cycles or loops, whereas the tree doesn't have any cycle or a loop. So what is a spanning tree then? A spanning tree is a subset of an undirected graph that has all the vertices connected by minimum number of edges. So here, once you start with any vertex of a graph, it has to be connected to all other vertex by the minimum number of edges. That is called as a spanning tree. It spans. The connection spans the whole tree. That means it includes all the nodes of the tree. If all the vertices are connected in a graph, then there exists at least one spanning tree. In a graph, there may exist more than one spanning tree. So, for a graph, we can draw more than one spanning tree. Depending upon the number of nodes available and the connectivity, we can be able to draw more spanning trees. Let us see the properties of a spanning tree. A spanning tree does not have any cycle. Generally, a tree has no cycle. Likewise, the spanning tree also has no cycle. That means there is no closed loop, and any vertex can be reached from any other vertex. That means if we start with one vertex, we will be end with the vertex which is not yet being visited. That means this is the example given for a spanning tree. So you can see here there are many edges and vertices here, and we can see the darkened lines of the edges which connects all the vertices. Okay, so starting from the first vertex, now it is connected to, you can see the lines. There is no loop is available. There is no loop exists in the spanning tree or any tree. Okay, so all the nodes 1 2 3 4 5 6 7 8 9 are all connected, and the connections are shown in the darkened lines. So the line drawn between those vertices that spans all the vertices is called as the spanning tree. Let us see what is a minimum spanning tree. A minimum spanning tree, MST, is a subset of edges of a connected, weighted, undirected graph that connects all the vertices together with the minimum possible total edge weight. Normally, we can assign some weight to the edges of the tree. Okay, so while spanning the tree or while visiting the nodes of the tree, as the name implies, this spanning tree spans all the nodes of the tree. And what is the minimum tree is the spanning distance or the spanning cost of those minimum number of nodes. Okay, that means here it's a subset of the edges. That means the minimum spanning tree is a subset of the edges that is corrected, weighted, undirected graph. That means there is no there is weighted and there is no direction. That means the directions are bidirectional. That means the edges are connected to one another. Okay, so these edges connect all the vertices together with the minimum possible edge weight. So here the edge weight may be the distance taken to travel or the time to do some process or any unit. Okay, so when the unit is minimum, that spanning tree is called as the minimum spanning tree. To derive an MST, we are using the Prime's algorithm or Kruskal algorithms are used to derive the minimum spanning tree from the given graph. Now let us see an example with a weighted graph. So we can see the edges are connected 1, 2, 3, 4, 5, 6, 7, 8 and 9 are there, and also we can see the edges. It's a weighted graph. Earlier we have seen the graph which is non-weighted graph. No values are assigned to the edges. Now it is a weighted graph. Now edges are assigned some values. Okay, so now here in this graph we have shown a spanning tree, though it is not the minimum spanning tree. So this is an example of a spanning tree where all the nodes 1 2 3 4 5 6 7 8 9 are connected. Okay, so the darkened lines shows the connection. This is a spanning tree. That is one of the spanning tree. So as we have seen just earlier, a graph can have more than one spanning tree, and after finding all the spanning trees, the cost of the spanning tree which is minimum is called as the minimum cost spanning tree. Okay, so now we can see here we start from the location 1, and every time you move to the next vertices, we have to check which is cheaper, which is less. So from 1 we are having two values, 2 and 5. Okay, and we are going to connect the next vertices, which is 1 to 2. Okay, and now from 2 we can go to either 4, 5, and accordingly we are connecting the using the values 2 to 5, and here 2 to 4, and now from 4 we can reach 3. Okay, so now the vertices 1, 2, 3, 4, 5 are connected, and then from the 5 we can connect to 7 and 6. So it has some edge values are there, and now this 7, from this 5 we can connect 7, and 6 is connected to 8 as well as to 9. So now all the vertices are connected. This is a weighted spanning tree, and just you are drawing any random spanning tree, and the value of this spanning tree is 38. Now they added all the values. 5 plus 2 plus 7 plus 3 is 10, 10 plus 3 is 13, plus 2 15, plus 7 22, and then plus 8 30, and then the vertices all the values of the vertices are added, so that we got the values as 38. Okay, 5 plus 7, let's just start from 1 to 2, 2 to 3, and all the values. So it is 5 plus 7 plus 3 plus 3 plus 5 plus 8 plus 3 plus 4. The total value is 38. Let us see another example which gives the minimum spanning tree. So the same graph is taken, but the tree here drawn is a different spanning tree. Now this is considered to be the least cost spanning, that is the minimum spanning tree. So how it is minimum? So let us see how to draw the minimum spanning tree. Now the value we got is 23. So how to get this? Start from the node 1, and we check where all we can reach. So from 1 we can reach either to 2 or to the vertex 3. Among this 2 and 3, which is cheaper? This 3 is cheaper, but value is 2. So compared to 5 and 2, 2 is cheaper. So select the line from 1 to 3. So darken it. From 3 we have to go to 2. There is no other way. So connect the values from 3 to 2, and the value is 2. Okay, and now again 4 is connected. There is no other way. We have to go to 4. So we have to connect between 3 and 4. The weightage is 3. Okay, afterwards from 4 we have to go to 5. Okay, and there is no other way. Even there are ways, but if you from 4 if you go back to 2, you will get a loop that is not allowed. And also we have two different values, 3 and 2. 2 is cheaper, so we are going to the vertex 5, sorry. Okay, then from 5 we can go either to 6 or to 7, but going from 5 to 6 is 8 unit of time, and 3 and 5 to 7 is only 5. So we choose the minimum. So 5 to 7 line is drawn. So we have started from 1, went through 3, and then we also spanned 2, 4 and 5, and then from there we are using the next node, which is 7. Okay, from 5 it is 5 we are going to 7, it has to be connected, and again it is actually cheaper because 5 to 6 is 8 and 5 to 7 is 5. So 5 is cheaper, so we are going to from the node 5 to 7. Then from 7 there is no other go, we have to go to 8. Okay, so the value is 2, there is no need of comparison. So wherever you start from one node to the other node, first we have to check for the connectivity. After the connectivity is checked, you have to go whichever is cheaper. Okay, so now coming to 8, we have to go to 6. There is no other option. So if you go again to 5, it will be a loop. So from 8 you have to go to 6, and that is the value is 7. 7 is the cost, and from 6 we can go either to the value is actually 9. We have to go to the 9th node, the value is 4. Okay, so here this spanning tree has the minimum cost as 23. Earlier it was 38. So now even here all nodes are connected, but in some different order. So now the value is 1, 3, 4, 2, 5, 7, and then 8, 6 and 9. So accordingly we have connected the values. The values are 2 plus 2 plus 3 plus 2. Just you are adding all the values of each and every vertex. So this is 2, and again this is the 2 and this is 3, and from here it is 2, and then here it is 5, and then it is 2, and then it is 3, and then it is 4. Okay, so we have reached the end of the checking. Now the value is 23. Okay, so now we have drawn the minimum spanning tree. There is no more spanning tree in this graph which costs less than 23. That means this is the minimum cost spanning tree. So that's all the way how to find out the minimum spanning tree. So start with any vertex and you have to connect all the vertices, and if you choose the minimum value, that is called as a minimum cost spanning tree. So this will be helpful in many mathematical applications and day-to-day applications. Hope it is easy to follow, and thanks for watching.